Hi class, how are you today? The expression on your face just says everything. The learning target for today is to be able to factor quadratic expressions when a equals 1. We'll get into more what that means, but a is going to be our leading coefficient, the number in front of x squared. For the scale, you're a 3 if you can factor quadratic equations when a equals 1. You're a 2 if you can factor quadratic expressions when a equals 1 and c is positive. You're a 1 if you can factor quadratic expressions when a equals 1 and b and c are both positive. And you're at a 0 if you cannot factor any quadratic expressions. Let's get started. All right, so as we've talked about before, quadratic expressions are in the form ax squared plus bx plus c. So these were the a, b, and c I was talking about in the learning target and scale. So a is the number in front of x squared, b is the number in front of x, and c is the constant term, the number by itself. Today we're only going to be dealing with quadratic expressions where a equals 1, where there is no number in front of the x squared, so we say that that's 1, because 1 times anything is itself. Now, we're going to be looking at 4 different problems here, and if you notice the signs of b and c are all different in each. So the first one we're going to do is the one where b and c are both positive, here on the left, x squared plus 9x plus 20. And to do that, we look at c to start, the number by itself, which in this case is 20. So we say, all right, what two numbers can multiply to 20? We're looking for all what we call the factor pairs of 20. So what two numbers will give you 20 when you multiply? That's 1 times 20, 2 times 10, and 4 times 5. Could also say 5 times 4, 10 times 2, and 20 times 1, but we only need them in one order. Now, which of those pairs will add to give you 9? The term in front of x, b. So we say what two numbers can multiply to c that will add to b. So 1 plus 20 is 21, that doesn't work. 2 plus 10 is 12, that doesn't work. 4 plus 5 is 9. So we're going to be dealing with this pair here. So when we write it out, it's going to look like this. And we're going to say x plus 4, x plus 5. And this will look familiar because this comes back to multiplying polynomials. So when you were multiplying polynomials, when you multiplied x plus 4 and x plus 5 out, you would get x squared plus 9x plus 20. So we are going backwards. Just like factoring using the GCF was the backwards version, or the opposite version, or the reverse version of the distributive property, factoring quadratics is the same with multiplying polynomials. We're doing the opposite. We're going backwards now. All right, this next one, we've got 6. So we say, what two numbers multiply to give you 6? Well, 1 times 6 and 2 times 3. However, notice that we have a negative sign here. So 1 plus 6 is 7, that's not going to work. 2 plus 3 is 5, but it's positive 5. So we can also look at the negative versions of this. Negative 1 and negative 6, negative 2 and negative 3. And they work very much the same. So negative 2 plus negative 3 will give you negative 5. So this is the one that works. So we say x minus 2, x minus 3. And again, you can check these by multiplying them out to see if it will work. And that will help you figure out if you did it right to check your work. So that's when C is positive. It gets a little bit different when C is negative, because now we've got negative 9. Well, what two numbers will multiply it to give us negative 9? So negative 1 and positive 9, 1 and negative 9, and 3 and negative 3. Could say negative 3 and 3, but again, those are the same number. So which one of these pairs will add to give us negative 8? Well, we've got negative 1 plus 9 is positive 8. 1 plus negative 9 is negative 8. So it's going to be this one here. So we're going to have x plus 1, x minus 9. And for this last one, again, it's negative, so we need both. And which two numbers can multiply to give us negative 30? So we've got negative 1 and positive 30, positive 1 and negative 30, negative 2 and positive 15, positive 2 and negative 15, negative 3 and positive 10. And I could keep going. There are more than this. However, note that we've got negative 3 plus 10. You should check these as you're going to see if they work, so you don't have to write out all of them. There is a lot for negative 30. There's a few more that we will have, but stop once you see the one that works. So obviously, negative 1 plus 30 is 29. The next one is negative 29. Negative 2 plus 15 is 13, so the next one's negative 13. And then negative 3 plus 10 is 7. Boom, that one works. Go with it, don't go any farther. Once you get the one that works, you can go ahead and stop. And so we have x minus 3, x plus 10. And that's it. The first terms are always going to be x. It's always going to be x plus or minus something times x plus or minus something. We'll get into the bigger ones as we go, the ones that have a number in front of x squared, where a is something other than 1. But we're starting off with this, and it's just finding the factor pairs, the numbers that multiply to c, and then find out which one of those will add to b. And then you can just go from there. Now it's time for the sponge activity. So 4 questions very similar to the 4 I just did. Number 1 is x squared plus 9x plus 18. Number 2 is x squared minus 4x plus 3. Number 3 is x squared minus 8x minus 20. And number 4 is x squared plus 3x minus 4. I want you to factor these, just like I did before. All right, that's it for the lesson. Once again, please make sure to take notes of the entire lesson, take a picture of everything, submit it all to Google Classroom, and have a good night.